is Roy, and our project is called Kessler Syndrome. So I will go a bit about what is the Kessler Syndrome. Kessler Syndrome is a chain reaction in Earth orbit where collisions between satellite and debris create more debris, increasing the likelihood of further collisions. And over time, this will cascade could make a certain orbital regions unsafe or unusable for satellites and space missions. And I move on to Rishabh to go over the project goal.
Hey everyone, I'm Rashad. I'll quickly take you guys over the project overview as well as our goals for the project. So Kessler Syndrome is an interactive platform that helps people visualize and explore objects in low Earth orbit, or also what's called LEO. We wanted to make something that takes a topic that can feel really technical and make it easier to understand and interact with. Our project is meant for a broad audience, including students, space enthusiasts, and the general public. Because of that, one of our main goals was to make the platform beginner friendly. We did not want to make it feel something only experts could use. We wanted anyone to be able to open it up, explore what is happening in orbit, and learn something from it. Another big goal of our project was to let users interact with and analyze objects in low Earth orbit in a more engaging way. Instead of just reading about satellites and debris, users can actually explore and better understand what is happening in space. Overall, our goal was to turn a complicated space topic into something people can actually explore and understand. Next, I'll pass it over to Sam to give us a quick demo.
Great, thank you. Yes, I'm Sam, and I'm going to go over a demo of our application, which is a web-based application. So when the user opens our application, as you can see, it's hosted here. When they go to the URL, the screen is going to pop up. The first thing they're going to see is a help menu. We've added a large amount of information here to make this beginner friendly, like Rashad was talking about. So we have tutorials with references, instructions. We have terminology, team members, sources, and just a general about page. The user can reference this anytime to familiarize themselves with the project, and it really makes the learning curve just a lot less steep for the user. When we exit out of this help menu, we are shown the main object orbit simulation page. So this is all the live locations of objects in low Earth orbit. And this screen fulfills our goal of just allowing the user to do basic interactions with objects in low Earth orbit. As you can see, it can move around on the globe. The user can filter objects. We have filters by altitude, filters by type, country, and collision risk. User can toggle any of these boxes to show certain objects to just narrow down what they're seeing. We also allow the user to speed up and slow down the orbit of objects. You can also go in reverse. We also allow the user to search by object name or object ID. The user can also click on a certain object and get information on said object. And we have information loaded in for every single one of these 14,000 objects. So really just a wide range of features that allow the user to interact with these orbits and just play around with these objects. And again, the key here is we want it to be beginner friendly, accessible to everybody. So we have lots of help options for the user. We also have an AI chatbot. This kind of plays into the help option for the user, help them learn about our application and its features. And then we also have a variety of just fun resources for the user, like changing the globe shape, the texture on the globe, things like that. The second major core aspect of our project is the Kessler Syndrome simulation page. So this is where we are simulating this Kessler Syndrome, which was talked about earlier, where objects collide and cause chain reactions. So on this page, again, we had the goal of making it user-friendly. So we already have loaded in default settings for the user, and all the user actually has to do is click this apply and start button. And we already have a C corpus of data loaded in for the user. So if they click this button, it will run a simulation right out of the box. They don't have to do anything else. And it will load the simulation, all the information, and you'll see the simulation is then rendered on the screen here. You can see collisions occurring. The user gets live updates on the stats of the simulation up here in the top right. The user can still filter by altitude here. They only want to see certain objects. And you'll notice this was a short simulation, it finished. We have functionality to allow the user to like save simulation stats. The user can also upload custom objects either via CSV or manually entering in the options here on the left to customize their simulation even further. And that sums up the core functionality of our application. And with that, I will move on to Will to give a overview of the system architecture. There we go.
Thanks, Sam. Hi, I'm Will, and I'm going to be talking about the tech stack and the architecture of our application. So, a core of our application is data. We have a lot of orbital data that we're working with. We choose to get that from Celestrack, and we have about 14,000 objects that we're getting from Celestrack. We have a Python ingestion service which pulls in that data once a day, puts it into our Postgres SQL database, and then once we have it in the database, we can pull that into our Rust backend service, which has two different modules. The first module is the simulation module that's going to pull in that data and do all the calculations on it. So we'll do calculations to predict the orbits and then also do calculations for collision simulations. And then the second module is an API module. And what that does is it takes the data or the results of the simulations and it actually serves it as a REST API. We have this, all of this side is hosted on AWS, and then that EC2 instance will reverse proxy through Nginx to that Rust API module, where the front end, which is hosted on GitHub Pages, can actually fetch from that API. The front end is also hosted statically, and we are relying heavily on a library called CCMJS. This allows us to easily display the globe and place the objects around it geospatially, as well as giving us some other functionality like the time lapse, and then all the rest of the functionality was built on top of that. That's our presentation. We are Kessler Syndrome. Thank you for listening.